In this video, I will be going over methods to compute limits. The first method is direct substitution. And this is where the limit as x goes to a of f of x equals f of a. So here we plug in x equals a to the function. And this occurs when f is a polynomial or rational function. And a is in the domain. So for my example, I have the limit as x goes to 3 of 5x cubed minus 3x squared plus x minus 6. So here this is a polynomial, so I know that I can just plug in x equals 3 to this function here. So that gets me 5 times 3 cubed minus 3 times 3 squared plus 3 minus 6. And that will be 135 minus 27 plus 3 minus 6. And this will be 105. The next example I have is to factor to cancel. So here we're going to do this when we have the limit as x goes to a of px over qx, a rational function, where q of a equals 0 and or p of a equals 0 when we initially plug it in. So I have the limit as t goes to negative 3 of t squared minus 9 over 2t squared plus 7t plus 3. So here we can see that if we plug in negative 3 to the top, we're going to get 0. And if we plug in negative 3 to the denominator, we will also get 0. So in this case, I'm going to factor. So t squared minus 9 is the same as t plus 3 times t minus 3. And then the denominator will be 2t plus 1 times t plus 3. So now we can cancel the t plus 3 from top and bottom, and that would actually be your hole in the graph, t equals negative 3, the portion that you cancel out. So now we have the limit as t goes to negative 3 of t minus 3 over 2t plus 1. And at this point we can plug in negative 3 for t. So we get negative 3 minus 3 over 2 times negative 3 plus 1. So this will be negative 6 over negative 6 plus 1, which is negative 6 over negative 5, or in other words, 6 over 5. Now another method you can use is expand and cancel. So here we have the limit as h goes to 0 of 2 plus h cubed minus 8 over h. So as we can see, if we were to plug in 0 to this function, we would get 0 divided by 0, which will not tell us anything. So we can expand this, and then we'll be able to cancel out h later. So 2 plus h cubed is h cubed plus 3h squared times 2 plus 3h times 2 squared plus 2 cubed, and then we're going to do minus 8. And this is all divided by h. Simplifying further, I have h cubed plus 6h squared plus 12h plus 8 minus 8 divided by h. And I can cancel the 8 and the minus 8. Then I get the limit as h goes to 0 of h cubed plus 6h squared plus 12h divided by h. Now I can factor out an h from the numerator. I'll get h times h squared plus 6h plus 12 divided by h. Cancel these out. Then I'll get the limit as h goes to 0 of h squared plus 6h plus 12. And now if I plug in h equals 0, I'm left with 12.